Welcome to Chapter 4, Day 2, all about solving and graphing absolute value equations. So the biggest thing we do today is watch out that absolute values will always be positive, right? That's a known fact. However, what's inside an absolute value could be positive or negative. When you take the absolute value, then it's positive. So let's just go through an example. I'll explain what I just meant. So I'm saying this x plus 12, it could equal -9, or the x plus 12 could equal +9. I am in a way breaking out of the absolute value. This in an absolute value would give me +9. This in an absolute value would give me +9. Okay, so I'm not changing anything. Notice the sign from the absolute value is still there, but the answer can be positive or negative. Now we solve both, so subtract 12, -21. Subtract 12 again, you'll get -3. These are your two answers that will make this a true statement. Oops. Now, the one thing about absolute value equations, we need to check for extraneous solutions, which means take your answer, plug it into the original equation, and let's make sure it's a true statement. If it is, then you're good to go. That's an answer. If it is false, then you have an extraneous. Make sure you cross that option off. Okay, so we're going to check for our extraneous solutions. You're going to have to do this from now on. So I take the original equation. Instead of x, I'm going to plug in a -21. And I'm asking myself, question mark, is this true? Well, absolute value of -9, does it equal 9? I would like you to go all the way to show me yes. Left side equals right side. First solution is good to go. Let's check your next solution. Plug in -3. Does it equal 9? Again, I'm plugging into the very, very original. Well, that is absolute value of 9 equals 9. Ooh, question mark. Yep, 9 equals 9. So I'm good to go. No extraneous solutions. This is a true statement with those two answers. Next, notice there's a couple things working outside of the absolute value. You need to get rid of all of that first. Then you can break out of the absolute value. Then you can check for extraneous solutions. So let's add 5. Divide by 3. Now this looks just like the problem that we just did. You have a solo absolute value equaling a positive number. Well, from here, you can notice that whatever's in the absolute value, 2x minus 3, could equal -3, or what's in the absolute value could equal +3. Both of those results will give me a +3 coming out of the absolute value. Okay, solve this quickly. I get 2x to equal 0, x equals 0, 2x equals 6, x would be 3. Okay, these are my two answers. I'm not sure yet if they are actual answers or if they are extraneous. So I have to do my check step. You need to check both answers. It's no rhyme or reason. If one is a correct answer, the other one might not be. They might both be extraneous. You might have one extraneous. You don't know, so you need to plug in. I like to go back to the original because in case I made a little computation error, I'll hopefully be able to correct it if I go back to the beginning. So I'm plugging in 0 first, and I'm putting that question mark. Is this true? What's this 3? Absolute value -3. Can't tell yet. I know the absolute value of 3 is +3, so if I multiply, that's 9. I get 4 equals 4. Okay, so x equals 0 is a good answer. It's not extraneous. Checking the next point of 3. Times, that's 6 minus 3. Please make sure you're putting that question mark as you go because you don't know if it's true yet. Getting here, yep, left side equals right side. So these are both true answers, not extraneous, because I checked my work. Here's another example. Again, there's something outside of the absolute value that's in its way. So I need to get rid of that first. And now it's something that I can work with. Hopefully something's jumping out at you at this point. Notice an absolute value. Can that ever be negative? What comes out of the absolute value? Well, no, it can't. This is when you can stop and just say no solution, because an absolute value cannot equal a negative value. Think about absolute value. It means distance from 0. Well, you can't have a negative distance. You might go to the left, but that's not negative. You're still physically moving in a positive manner. So as soon as you get to here, a lot of people want to break this out of jail, but you have to realize an absolute value completely by itself will never result in a negative number. So watch out for those. I even started. Super important. Next one, again, there's something acting on this absolute value. You do not distribute. Think of this as like jail bars. Okay, you'll never distribute into jail. They kind of stay by themselves. So what you're going to do is divide by 3. You get 3x would equal absolute value of 2x minus 1. This looks very similar to the ones above. I have an absolute value equal to what we assume right now is a positive number. We don't know what x is yet. So we can do exactly what we did before. Break this out. The 2x minus 1 could equal negative 3x. And the 2x minus 1 could equal positive x. Solving these, I would get 5x equals 1. X would equal 1/5. Solving here, I would get negative 1 equals x. So I like to just always rewrite it like that. Okay. So these are my 2 answers. I'm not done though. You need to check your answers. I even like putting a different color so I know, yes, I checked. Let's plug in my first choice. Yes, we do have to deal with a little bit of fractions, but if we leave it in terms of fractions, it's actually not that bad. Okay, so that's 2/5 minus 1, or 2/5 minus 5/5, so negative 3/5. oops, I forgot my question mark. We're trying to see if this is true. Absolute value of negative 3/5 is positive 3/5 times 3 is 9/5. So good to go. The first answer is correct. Checking the next answer. I'm asking if this is true. So does negative 9 equal? This would be negative 3. Negative 9 does not equal positive 9. Not true. So this is not a solution. I'm actually going to erase this and this now. X minus 1 is what's called extraneous. Do not have that as an answer choice. This is your only answer that works. We expect to see this on a quiz where you go find your possible answers, check, and then cross off extraneous. Okay, almost done. This one gets a little more complicated. Only reason is now you have a couple terms on the right and left, but it's the same idea. Get your absolute value alone. Good, I have it alone. Now I can break it out, set what's inside equal to the negative of what's outside, and set the inside equal to the positive of outside. Please notice I put, the negative sign in parentheses to know that you have to distribute to both terms. Please pause the video and try to solve this problem. Okay, hopefully you paused the video and solved. If you did it right, you will see that the answer is x equals 6. If you got that right, do a little dance. You did it. If not, I'm going to go through it right now so we can clarify. So, first one, this would be x plus 10 equals negative 4x plus 8. When you solve, we'll get 5x equals negative 2. So one answer choice would be negative 2/5. The other one, when I solve, negative 3x equals negative 18. So the other choice would be x equals 6. Okay, again, I'm saying choices. Hopefully you notice that change in my vocabulary. Now I have to do my check step. Let's plug in both answers. First one, again, into the original. Negative 2/5 plus 10 plus 8. Does that equal 4 times negative 2/5? Okay, so I'm getting here negative 2/5 plus 10 would be 48/5. Does it equal negative 8/5? So looking at this, I don't even need to go much further, but notice 48/5 plus 8. How could that ever be negative? Like, it's not going to happen. If I keep going, it's 88/5 equal negative 8/5. No way, Jose, not possible. So that's why you have to cross off this answer choice. When you check x equals 6, it will work, but let's just make sure you are able to get there. You get 16 plus 8, which is 24, indeed equals 24. So So if you got this right from the beginning, nicely done. If not, please look at the work and correct. It probably was in your initial solving. Okay, last problem. This is based off of the discovery that we did the day before. So hopefully you have an idea of what this graph looks like. We're going to ask for a couple information on the side and then the actual graph. Hopefully 3 to 5 points like a normal homework assignment. So looking at this problem, I know it's going to open down because of that negative sign. I know the width is going to be 2 because of this 2 in front. I also know the vertex, and I'm actually going to write that down as a point. We'll put in our XY table, yes, but it would be -1, 3, the opposite of what's inside and the same as what's outside. Again, that should have been clear from your discovery. So I'm going to put my vertex in the middle of my points. I'm going to put even a little V next to it. I'm going to graph it, and I know it's going to open down. I'm going to pick a couple points to the left, a couple points to the right, and I'll be good to go. Okay, that vertex really tells me where my graph is changing shape. So I'll pick maybe these points. Going to the original, if I plug in -3, get -2, absolute value, -3 plus 1, plus 3, I am getting -1. If you go back, plug in -2 into the highlighted equation, I get 1, and you should get these as well. Make sure you're showing work for that, or if you don't understand, please ask during class. But when I graph that, notice this beautiful V shape. I know it's a V shape because of the absolute value. It opens down like I thought. And you have that vertex of -1, 3. Okay? Looking at the highlighted equation, you'll get a lot of information about what it should look like. Once you plug in points, that confirms what it's going to look like. Okay, please take your time on these. Make sure you check for extraneous solutions, and good luck.